What we're looking at here are PISA scores. This is the Program for International Student Assessment. This is an international assessment that happens every 3 years. It gets a lot of news, mostly because the United States doesn't do as well as we would like us to do. There's a math section, a science section, and a reading section. And I believe this score is out of 800. These scores on this page are the scores from the 2006 exam. So, our first objective here is to calculate the statistics. The calculator has the ability to do this, which is very handy. So once you've entered the data into a list, let's say L1, then you press Stat, 1 to the right, Calc, and that's where you will find 1var stats. It stands for one variable statistics. This is used when you want to calculate mean, median, quartiles, min, max, standard deviation, all the basic descriptive statistics for a single variable, a single quantitative variable. There's some things about the newer OS that I do not like, so I actually stick with the older OS. So if you get a screen like this, you're on the older OS. And if you just press enter, then it will, by default, assume that you want L1. You could specify a list like L1 by doing second one, but like I said, it's not necessary because by default it will assume that you want L1. If you're on the newer OS, then you'll just get what I think is called the Stat Wizard screen to show up, which looks like this. You'll just say L1, you'll leave freak list blank, and then you'll press enter on calculate. So there's a bunch of stuff here. I'll explain each one. The first one is the symbol for the mean of the variable x. Anytime we place a bar over a Latin letter, it signifies the mean of that variable. And we call it x bar. It means the mean of x. So the average score of all these countries that took part in the PISA exam in 2006 was 486.45. Just some more background on the PISA. The PISA is run by the OECD, which is the Organization for Economic Cooperation and Development. It's a group of the 30 wealthiest countries in the world. However, some non-member countries take part in the PISA because they want to know how their students rank against the rest of the world or other countries. Also, this exam is given to 15-year-olds, and the questions are focused on application, which means taking your knowledge and understanding and applying it to a novel situation. And some may argue that U.S. students do not do a good job at this. That's why you'll see in the newer assessments like the PARCC, which is what New Jersey is using, the questions are more higher level questions, application questions, analysis questions, not just solve 2x plus 5 equals 0. Okay? So we're trying to raise the bar for students here in this country. Other things from the screen. This is the sum of the list. We're not going to use that, but just for your information, the sum of all the scores. This is the sum of all the squares of the scores. This is Greek letter, capital S in Greek, aka sigma. Yes?
Why would we need to know the sum squared?
There are some formulas in statistics that use this.
So it's a thing.
It is. It's not just random. Yeah. This is the standard deviation. We'll talk about that later in this chapter. This is also the standard deviation. This is Greek letter S. Okay, this is capital Greek S. This is lowercase Greek s. I did not make their alphabet up. I do not know why their uppercase S looks so different from their lowercase s. And when you put an S at the end of a word, it looks different, okay, than that even. This is sigma, standard deviation, sum. That's why we use the Greek S, because our words start with S. This is standard deviation for population. This is standard deviation for a sample. We'll talk more about that later. This is the number of values, 40. That's how many countries there are. And then scroll down and you get the 5-number summary. Very useful. So the lowest score was 365. That was Tunisia. They have some work to do. The first quartile, the 25th percentile country or score, was 470. That means that about a quarter of the countries performed lower than 470. The median, the middle value, is 495.5. The reason you don't find that in the list is because you have an even number of values, so the median is the average of the 20th and the 21st country. But that's how we define median. Third quartile, the 75th percentile score, is 521. That means about 3/4 of the countries did worse than that, and about a quarter of the countries did better than that. So if you did better than 521, you are in the top 25%. And finally, the highest score, 548. The 5-number summary, although it looks simplistic, you can garner a lot of information from it. The range and the IQR must be calculated manually. You could write a program that did that for you, but it's not difficult to calculate. So the IQR is the difference in the quartiles, and the range is the difference between the min and the max. Okay. So the range of scores is 183, and the interquartile range is 51. That's the spread of the middle 50%. Any questions on using one variable statistics and how to interpret any of its output? Very useful function. We'll be using it quite a bit. Like I said, even though this is ancient technology, it serves our purposes. It does everything that we need in this class. Okay, so now we will introduce your first objective measure of an outlier. We've talked about outliers, but we've never had an objective measure. This is thanks to John Tukey. It's very simple. You take the third quartile, 521, and you add 1.5 IQRs to it, 1.5 box widths. And the fact that you do this accounts for the variability that exists in the data set. Okay. So 1.5 times 51. $597.5. So what this means is that any datum that is above 597.5 will be considered an outlier. This is also called the upper fence. So anything that's above it is an outlier. Now, let's check. Are there any values above the upper fence? Well, just look. Compare the upper fence with the maximum. So, deduce. Are there any values above the upper fence? No. Any questions on that? List the highest value in the data set that is below the upper fence. What is it? 548. And as I indicated here, this is where the right whisker will extend to. So when we create our box and whisker plot that shows outliers, the right whisker will go to the highest value that is not an outlier. Please note, this is John Tukey's test. There is no objective definition of an outlier that everyone in the statistical community agrees to. But we're giving you something to start with. When John Tukey was asked why 1.5, he said because 2 would be too big and 1 would be too small. Okay. There's actually some sense to his comment, though, that we'll explore later. Remember, this dude had a PhD in mathematics. Okay? He probably had some good reasons. Now, the lower fence. We're going to go 1.5 box widths less than the first quartile. So, what's Q1? 470. $393.5 is what our lower fence is. So any values that are below that will be considered outliers on the low end. Okay, now look, your minimum is 365, so that means that you at least have one outlier on the low end. Let's sort the list. Tell me out loud, how do I sort? Stat, sort A or D, and the list, so L1. And then go back into your editor, and now your data is sorted. Handy feature. So now we can easily see the countries that are below the lower fence. There are 3 of them. $365, 370, and 391. Okay, so as per Tukey's test, Tunisia and Brazil. And what was the third one? Indonesia, thank you. So these countries in particular we're going to examine. We want to make sure that these are valid because they are so different than the rest of the group. And if they are valid, we at least want to understand their effects on statistics like the mean. Okay. Also say out loud, what is the lowest value in the set that is above the lower fence? 406. Very good. That's where the left whisker will extend to, or start from. Okay? Before we draw the modified box and whisker plot, the one that shows the outliers, any questions on any of the questions above that? So know how to find the upper and lower fence, know how to determine if something is an outlier as per Tukey's test. Not only will I require that, the College Board will require that. Okay, so here we go. We are going to indicate outliers with an asterisk. You just want some symbol that's easy to distinguish. I probably should scale this appropriately. So if I look at my min and max, 365 to 548, I want to cover that. And maybe I also want to cover the upper fence, just to show you that. So what I'll do is make sure I can cover 233.5 points. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Divide that by 31. 7.5. So just to make the math easy, I will go by tens. And I'll start with a multiple of 10, so maybe 390. Oh, I'm sorry. Thank you for pointing that out. Let's start from 360. I got my lower fence and my minimum mixed up. So label your scale. You don't have to use the one I'm using, but make sure you can cover the whole range. Okay. So first, the outliers. 365, I'll use an asterisk. 370, another asterisk, and 391. Next, the left whisker. It's going to start at 406. So I'll put a little line segment there at 406. Next, the box starts at Q1. That's 470. So that's our next mark. A larger line segment there because we're starting the box. The median, 495.5. A line segment there of equal width as the quartile line segments. Then the third quartile, 521. Okay, and then a line that connects the left whisker to the left edge of the box. Draw the lower and upper boundaries of the box. The height of the box doesn't matter. And now the highest value that is not an outlier, which is in this case the same as the maximum value, 548. And we have no outliers on the upper end. And I also said draw dashed lines to indicate the fence locations. I want you to get a graphical sense of the fences. However, it is not necessary, like on one of my tests or on the AP exam, to draw these dashed lines. So my lower fence is 393.5. So about there. So as you can see, everything that's below that is an outlier. And then on the upper end, the fence was 597.5. Okay, so anything that's above that is an outlier. Now let's do it on the calculator. Your data is already in, that's the hardest part. The data does not need to be sorted for the calculator to do a box and whisker plot. What button should I press? Second, y equals. Let's go into plot 1. Make sure it's on. Let's choose the one that shows the outliers, which is the first one on the second row. Your X list should be L1. The frequency option should be set to 1. Choose whatever mark you want. And I noticed that I had my plot 2 turned on, so I'm going to turn that off. Now what button? Zoom 9, very good. Nice. What's called a modified box and whisker plot, one that shows outliers as per Tukey's test. You can press trace, and that will tell you the exact values of the outliers. It will tell you things like the first quartile, the median, third quartile, maximum. And then you can just recreate that on the paper. Okay. Any questions so far? Okay, next question. From the box plot, does it appear that the data is skewed? And if so, in what direction? Let's ask a random person. Lucy, what do you think? Skewed to the left. I agree 100%. Skewed in the direction where everything you own is in a box. I think that joke is getting old. It's time for a new one. Notice that the tail on the left-hand side is longer. And notice that you have outliers on the left-hand side. Those will also contribute to the skew. The left tail is longer than the right. The calculator, as you saw, also has the option to ignore outliers, just so you're aware. And now the tail is very evidently much longer than the right tail. Okay. Okay. Any questions regarding skew? Great. So box and whisker plots, handy. You can tell exactly where the median is, where the quartiles lie, where the min and max is. Actually, this is the lowest number that's not an outlier. This is the true min. You can tell skew. You just can't tell modality, mean, or the mode. Great. Moving on. Now we're going to make comparisons. Box and whisker plots are great for making comparisons. You already have 2006's data in L1. Now we're going to put 2009's data into L2. Both columns. As you can see, the PISA became significantly more popular from 2006 to 2009. A lot of people want to be part of the game. Understand how their countries performed vis-a-vis the rest of the world. Okay, so enter that now. It's like 65 countries. A way that I like to verify that I entered the data incorrectly, other than just looking that I did, is to calculate the mean and to compare it with somebody else. So like before, I'll do stat calc 1. This time you need to tell it L2. So second 2. And somebody raise your hand and tell me if you also got 467.6. If nobody got that, then that's a pretty good indicator that I entered the data in incorrectly. I got 467.6 for the mean. Okay. Okay, so it looks like I entered the data incorrectly. Or correctly, excuse me.
I got this meter that was like 486.45.
That is for the 2006 exam.
Oh, I didn't.
You need to specify L2. Okay? If you're not getting this, check that you specified L2. And if you specified L2, check that you entered the data incorrectly.
Yeah, I got it. And I got Slay. I got 467.
Yeah, so maybe you entered a datum in incorrectly. Okay? So, the max, 600. Who got the 600? Glenn. Oh, no. You misinterpreted my question. My question is, what country scored 600?
Shanghai.
Yeah, it wasn't even a country, it was a city. So as you can see, they allowed cities to participate. And I would definitely not make generalizations about China from the performance of Shanghai. Yes?
No, but they also pick the country.
If you're making a generalization about the country from the city, then yes.
And then Chinese Taipei. And then Hong Kong.
Okay. The third quartile, 512.5. If you scored higher than that, you are in the top 25%. The median, 487. That's the middle country. Third quartile, 512.5. Minimum, 331. Another thing that countries do is track their performance over time. So for example, in the 2006 exam, the United States scored 474. This is an average of all the students that took it. What they do is a stratified random sample. That's how they get the students. And then in the 2009 exam, the U.S.'s performance increased, looks like 13 points. So that's positive. Other statistics are the mean. That's the first number, 467.6. Mara, were you able to eventually get that?
Yeah, I'm just looking on. I don't have to before.
Lucy, were you able to get this mean?
Yeah.
Okay. The range, 600 minus 331, 269. And the interquartile range, 512.5 minus, oops, sorry, I wrote down something incorrectly. That's what happens at this time of day. My first quartile is 420. So 512.5 minus 420. 92.5. So just by that, I can tell the scores are a lot more spread out in 2009, presumably because there are a lot more countries, and all of those countries that are now involved were not part of the OECD. So you have some developing countries that are part of that list. Also, the IQR is larger. So the spread of the middle 50% is also significantly larger. Now let's do the upper fence. 512.5 plus 1.5 IQRs. So any value that's above 651.25 is going to be an outlier. Let's check our maximum. It's 600. That is not above the upper fence, so therefore we do not have any high outliers. We don't have any countries that are standing out so far on the high end that we would consider them to be unusual and deserving investigation as being valid. Okay, and the highest value in the data set that's below the upper fence is 600. Please do not come away with this exercise with the conclusion that there are never upper outliers. I think you're smart enough not to do that. So the right whisker will go to 600. The lower fence, like before, 1.5 box widths under the first quartile, 281.25. Look at the minimum. It's 331. Notice that that is above the lower fence. So what can we conclude? No low outliers, right? Because the lowest score is above the lower fence. Okay. And the lowest value that is above the lower fence is the minimum, 331. Okay, as I've said, box and whisker plots are great for making comparisons. Yes? Yes, it's a good question. From here on out, is that how I want you to calculate the outliers? Yes, as does the College Board. So if on the AP exam you get a question regarding are there any outliers in this data set, they will assume that you will use the Tukey test. Now, as I said, box and whisker plots are great for making comparisons. So let's do that. We've done the hard part. We've entered the data in. So second y equals number 2. Turn it on. Make sure that you're using the one showing outliers, but actually in this case it wouldn't matter. Choose L2. And then you can choose whatever mark you want for the outliers. Again, in this case it doesn't matter. And we'll do zoom 9. Okay. Now I can easily compare. I can tell that the spread of scores in 2009 is greater than in 2006. I can also tell that the spread of the middle half of the scores in 2009 was greater than that in 2006. I can tell that the average, or more accurately the median score in 2009 was slightly less than the median score in 2006. In other words, this distribution is centered slightly to the left of this one, or slightly lower. I can tell that as per Tukey's test, there are 3 countries here that show up as outliers, whereas in 2006, most likely because of the greater IQR, that countries on the low end are not showing up as outliers. That doesn't mean that if we look at a histogram, we wouldn't classify them as such. Okay? Any questions on making multiple box and whisker plots? Yes?
Do you tell the skew by the whiskers or the box?
Mostly the whiskers, but sometimes the box. So, for example, in this one here, it looks like the left whisker is a little bit longer. It's hard to tell. What we can do is a calculation here. We can do 420 minus 331, and then compare that with 600 minus 512.5. Yeah, the left whisker is a tad longer. So that would be evidence that there's skew to the left. In addition to that, the median is closer to Q3. That's additional evidence that there's skew to the left. Okay? So I would expect that a histogram corresponding to the second plot would look like this. So you see how the tails are about the same length, but the bulk of the distribution is to the right. Okay? So that corresponds to a graph like this. Good question. I'm not going to make these on paper. I think you can do that. I think there's a lot more to be learned by just doing it on a calculator and knowing how to make comparisons. The next thing that we'll do is back-to-back histograms. So we've already discussed what the weaknesses of these are. They do not show individual data, they do not show modes, they do not show modality. So the histogram is definitely handy to cover up for those weaknesses. Okay. A thing that I have seen commonly done is to take advantage of the strengths of the box and whisker plot and the strengths of the histogram by putting them on the same graph. So what we'll do here is put a histogram here and then put a box and whisker plot above it using the same scale. That way you can use the box and whisker plot to tell exactly where the median and quartiles are, okay? And you can see how they match up. And I think